Alright, today we are going to talk about simplified expressions. So when we are simplifying things, we're making them smaller, easier to work with. So the two things that we need to look at when we're simplifying is we want it simplified when there are no like terms or parentheses in an expression. So you'll just kind of ask yourself each time, are the parentheses? Yes, I need to get rid of them. No, don't worry about it. Are there like terms? Yes, I need to combine them. If not, don't worry about it. So let's look at the first expression. We're going to do 5x plus 3 plus 2x. So first off, are there parentheses in this? Nope, we don't need to worry about this. What we do need to look at are the like terms. And we're going to use some manipulatives here to model it. So here we have 5x. So I've got 5 x's. We have 3 1's. And then 2 x's. So what I want you to do is highlight accordingly. So we're highlighting our x's in orange. We're highlighting our 1's in yellow. So I'm highlighting my 5x in orange and my 2x in orange. And then I'm highlighting my 3 in yellow. So looking at this, are there any like terms that can be combined? Yes. Our x's, I can just move these over to combine here. Now I have a total of 1, 2, 3, 4, 5, 6, 7 x's. Is there anything that can be combined with the 1's? No. So our simplified expression is we have 7 x's plus we have 3 1's. And if you're thinking about how do we get that 7? Well, it was easy to visualize when we just brought the x's over, but really we're just adding those coefficients. We have 5 x's and we have 2 x's. That gives us a total of 7 x's. Let's look at example 2. 2x plus 2 plus 4x plus 3. So again, first thing, are there any parentheses? Nope. What we need to worry about is our like terms. So let's model it again. We've got 2 x's. We have 2 1's. Then we have 4 x's. And 3 1's, which we need an extra for. Oh, I have it over here. Sorry. Okay, so again, I want you to highlight accordingly. Let's highlight our x's in orange. And I'm highlighting my 1's in yellow. We're highlighting those like terms. So what can be combined here? Just like before, I have my 2 x's here. I can combine my 4 x's with those 2 x's. That gives me a total of 1, 2, 3, 4, 5, 6 x's, which is what we would get when we add our coefficients. So we have 6x plus, I have 2 1's here, which can be combined with the 3 1's over here to make a total of 5 1's or 5. So 2x and 4x make 6x, 2 and 3 makes 5. So our simplified expression is 6x plus 5. Let's try some more. Alright, for example 3, we're going to do 4y plus 3x plus 2y plus x. So let's kind of visualize these with our manipulatives here. This time we've got y's, so we have 4 y's, we have 3 x's, we have 2 y's, and then we have an x. I'm going to highlight accordingly. So my y's I'm using my green highlighter for. And my x's I'm using the orange highlighter for. So again, we didn't have any parentheses. We're just worried about getting those like terms together. I have 4 y's here. I can combine my 2 y's with that. Bring that over. Now we have 1, 2, 3, 4, 5, 6 y's. I have 3 x's here. We can combine this other x here to make it 4 x's. So our simplified expression would be 6y plus 4x. Generally, when we are writing simplified expressions, we do them alphabetically. So you'll probably see me actually write this as 4x plus 6y. They mean the same thing, right? Using the commutative property, the order doesn't matter. It's just generally we do it alphabetically. The most common mistake that we see with this problem is people will add and they'll say, oh, 4y and 2y makes 6y. But when they add the x's, they're like, oh, there's 3 and there's nothing. So they'd say 6y plus 3x. Don't forget that this means that this just x isn't a 0 in front of it. There's one of them. So if you want to write a 1 in there so you don't make a mistake, then do it. The next one, 5 plus x plus 2y plus 4x plus z plus 4y. Again, we don't have parentheses. Let's just look at our like terms here. So we've got 5 1's. We have 2 y's. We have an x here. Sorry, I missed that one. We have 4 x's. We have a z, which we're using blue for. And then we have 4 y's. So let's highlight accordingly. Our 5 is a constant. We're going to highlight that in yellow. Our x's we're highlighting in orange. Our y's we're highlighting in green. And our z we are highlighting in blue. So let's combine our like terms. We've got 5 1's. Are there any other 1's to combine with? Nope. So we just have 5. I've got 1x here. Do we have other x's to combine? Yeah, these 4 x's we can move over to combine. I have 2 y's here. I also have these 4 y's over here that I can combine. And then I have z, and there's nothing else to combine with that. So simplified, we have 5 1's. Plus 1, 2, 3, 4, 5 x's, plus 1, 2, 3, 4, 5, 6 y's, and 1 z, which can just be written as z or 1z. Again, if you write it this way, it's fine. Generally, we do it alphabetically, so 5x plus 6y plus z, and we do our constant at the end. But both of them are correct, okay? And again, don't make the mistake with your x's. We have an x and we have 4x. That doesn't equal 4x. That's 1x plus 4x, which means 5x. Okay? Okay, number 5. 3x plus 3y plus 2. So let's visualize it here. We've got 3 x's, we've got 3 y's, and we have 2. I'm going to highlight accordingly. So x is in orange, y's in green, 2's in yellow. So I've got 3 x's. Are there any other x's to combine with? No. I've got 3 y's. Are there any other y's to combine with? No. I've got 2 1's. Are there any other 1's to combine with? No. So in this case, we don't have parentheses and we don't have any like terms. So there's 2 ways that we can write our answer here. We can either write it as the same exact expression, 3x plus 3y plus 2. So that's one way to write it. Or you can just write it is simplified. Already simplified. Okay. So we're going to put the manipulatives aside for a moment as we move into kind of some of these more complicated simplified problems where we have to think about the parentheses. Okay? So, going to do y plus 3 times y plus 2. So the first thing that it said we always ask ourselves, order of operations, we do parentheses first. Same thing for simplifying, we have to do parentheses first. So when we're looking at this, the first thing we see that there's parentheses. With any of your highlighter colors, I don't care which one, before we highlight the variables and the constants, I'm going to highlight this part here that's attached to the parentheses, including this 3. Because this 3 here, we need to distribute in order to get rid of the parentheses. So I want you to also draw those arrows from the 3 to both terms on the inside. So remember, when we distribute, 3 times y is 3y, plus, bring down your plus sign, 3 times 2 is 6. So we got rid of our parentheses, now we're going to bring anything else down. So I'm going to bring down my y and my plus. I don't need to bring down the 3 because we already included that when we distributed. Now I'm going to do my highlighting. So I have y's, which I'm highlighting in green. And we have our constants, which we're highlighting in yellow. So do we have any like terms to combine here? Yeah, we have a y and 3 more y's, which is a total of 4 y's, plus this constant has nothing else to combine with, so just plus 6. Let's do a couple more with that distributive property in there. All right, number 7. Plus 8x plus 2, and then in parentheses, 3x plus 1. So again, first thing we ask, are there parentheses? Yes, there are. So I'm going to highlight this part here that includes the number on the outside, because that's the number that we have to distribute. So I'm going to draw my arrows in, because the 2 needs to be multiplied by both parts in the parentheses. So 2 times 3x, well 2 times 3 is 6, so 2 times 3x is 6x. 2 times 1 is 2. And then we bring anything else down. Bring down my 7, bring down my plus, bring down my 8x, bring down the plus. Again, we don't bring down the 2 because we already distributed that. Now let's highlight. My constants are highlighted in yellow. And then I have x's that we're highlighting in orange. So I've got 7 here, and I've got 2 there, which can be combined to make 9. Then 8 x's and 6 x's makes 14 x's. If you write it this way, it's fine. Again, I said normally we put our variables first alphabetically, and then we put our constants second, but both answers would be accepted. All right, one more problem with the distributive property. Got 7 plus 3, and then in parentheses, 5x plus 2 plus x. And first question, are there parentheses? Yes, so I'm going to highlight that part in any color because that's where we need to start. And I'm going to draw my arrows from the 3 because that's the number that we need to distribute. 3 times 5x is 15x plus 3 times 2 is 6. Then we bring anything else down. Bring down the 7. Bring down the plus x. Now I'm going to highlight. I have my constants, which we're highlighting in yellow. And I have my x's, which we're highlighting in orange. So I have 7 ones and 6 ones, which makes a total of 13. Plus, we have 15 x's plus another x, which makes a total of 16 x's. If you leave it like this, it's fine. Again, we do our variables first and our constants second is the most proper way to write it. Okay? So we're going to give you two U-try problems, one without distributing and one with it. And we want you highlighting as you are completing those. We did all of our problems with X's, Y's, Z's. If yours are not, maybe like the second one is going to have A's or B's in it, I would highlight just according to alphabetically. We did X, Y, Z, do A, B, C, kind of going with that. So you try number 1, 4x plus 7 plus 3y plus x plus 11. And then for the you try number 2, we're going to do 9 plus 6a plus 5, and then in parentheses 4 plus 2a. Go ahead and try that on your own.